Hi, and welcome to today's video lecture on Group 2. Today we will be talking to you about the reactions of the Group 2 oxides. As an introduction to the oxides of Group 2, this is what the Group 2 oxides look like. They're colorless ionic solids at room temperature, starting from our beryllium oxide, magnesium oxide, calcium oxide, strontium oxide, barium oxide. As you can see, it's quite impossible to tell the oxides apart once you mix up the pictures. They all kind of look the same. For the reactions of the Group 2 metal oxides with acid, with the exception of beryllium oxide, all other Group 2 oxides are basic. Basic oxides react with acids to give salts and water. Are you able to use polarization to explain why beryllium oxide and most other beryllium compounds exhibit covalence character? Recall from video 4 on polarization, where we talked about the polarizing power of small densely charged cations and the polarizability of anions with loosely bound valence electrons. But in this case, are you able to tell who is the smallest, most densely charged cation? Beryllium oxide is amphoteric. Beryllium oxide can react with 2 moles of HCl to produce beryllium chloride and 1 mole of water, like all basic oxides do. But beryllium oxide is also able to react with 2 moles of hydroxides and 1 mole of water to form the berylate anion BeOH4 2-. The solubility of the oxides in group 2 with water increases down the group. You can recall from our chapter on solubility that for small anions, the lattice energy becomes weaker down the group because of the increasing interionic radius. Hence, magnesium oxide having the smallest interionic radius has got the highest lattice energy. It is very difficult to dissolve in water because it takes a lot of energy to overcome the high value of the lattice energy. Calcium oxide, strontium oxide, and barium oxide dissolve in water to give an increasingly alkaline solution. In summary, for the nature of the oxides, beryllium oxide is amphoteric, whereas all the other oxides are basic. With regards to reaction with water, beryllium oxide is insoluble in water, magnesium oxide is slightly soluble, giving a solution of pH 9, as you could recall from the chapter of periodicity, whereas calcium oxide to barium oxide exhibit a trend of increasing solubility due to weaker lattice energy because of the higher interionic radius. The pH also ranges from 10 from calcium oxide to 13 for barium oxide. Now, let us watch a video of what the metal oxides are able to do with water. Here, some calcium oxide is already in the bottle and water is poured onto it. The bottle is then capped, and you see the calcium oxide dissolving quickly inside the water with a build-up of heat energy, heating up some of the water into steam, and an explosion happens. Here is another demonstration of the things you can do with calcium oxide. You place an aluminum foil over it, put in some oil for good taste, spread it out well. To the calcium oxide, you add a small glass of water. When the calcium oxide begins dissolving, a large amount of heat is evolved, which heats up the aluminum foil. Break open an egg and add it onto the aluminum foil for the cooking to happen. Decide whether you want a sunny side up, a half-boiled egg, or a soft-boiled egg. Remove any eggshells that fall in, and well, just wait for the egg to cook. It cooks pretty fast. Grab a bottle of distilled water near you and add in more water for good measure if you wish to cook a sunny side up. Otherwise, if a soft-boiled egg would do for you, you can stop cooking at this moment. And then enjoy your egg. Thank you for watching this video. We'll see you in the next